Go ahead.
Another try on 9.5, apply composition of transformation notes. Starting out with our vocab here, we have two of them. Glide reflection is a transformation of a figure that includes a translation or a glide with a reflection. If you recall from chapter 4, we learned three transformations. We had the translation, which slides a figure across the graph. We had a reflection, which flips a figure over a line. And we had a rotation, which turns a figure around a point. With a glide reflection, we're matching two of those. We're gliding and then reflecting. Our second definition is composition of transformations. And this is when two or more transformations are combined to form a single transformation. So this can include two rotations, two reflections, maybe two translations all in the same thing, but most commonly it mixes and matches between the three transformations. What I really want to make sure to highlight for you is always use the newest set of points for your next move. When you start with the first set of points, you make your first move, and then always use that set of points you just found to make the next move. So let's try our example here at the bottom of the page to show what this means. We're going to find the image of this glide reflection. Now, a couple notes in the margin before we start this example. Over here, the book warned us that the line of reflection must be parallel to the direction of the translation to be a glide reflection. And basically what it means is if you take your figure and you move it left or right first, then your reflection has to be either the x-axis or y equals a number. If you remember that y equals a number is a line that goes across like this. If you have the up or down, if you move that first, then you're going to go with the y equals a number, y-axis or x equals a number, and if you remember x equals a number are vertical that goes like this. So this first one, if you notice up here, we have x minus 8. If you recall this from chapter 4, this should move our graph to the left 8 because it's dealing with the x. Anything with x is left or right, anything with y is up or down. Now, one thing I need to note before we go too much further in this video, I'm using a stylus on a screen. It could get a little sloppy, so please bear with me. I'm doing the best I can here. So hopefully you can still make heads or tails of what I'm trying to say and what I'm showing you in these notes. So sorry if it gets sloppy. So one thing I want to stress when you do these problems is make sure that you're writing down the ordered pairs and everything that's changing with those ordered pairs. So first thing I'm going to do is graph this triangle ABC with the points they give me. Always label because we're going to change these as we go along. So here's my original triangle. I'm going to come down here where I have a little bit more room and write all my ordered pairs out. And this is my original XY. Now, I'm going to go to my next change. I'm going to change colors here so that we can see the change happening here. My first change is this translation. So notice my XY is going to go to X minus 8Y. And that's what's happening to my ordered pair. So my ordered pair, this is going to become A prime, B prime, and C prime. If you recall from earlier, the first change every time gets a 1 prime. So I'm going to take my X of 2 and subtract 8, and I get negative 6. My Y is going to stay the same at 1. For B, I'm going to take my X, which is 5, subtract 8, I get negative 3, and leave my Y alone, so I leave it at 3. For C prime, I'm going to take 6, subtract 8, I get negative 2, leave my Y alone, so it stays at 2. Now I'm going to graph that new figure that's my first move off of this translation. Super important on the graph to put those prime marks on there. And there's my first move, my first translation. I'm going to switch colors again so that I can show you the third and final move here. Now I'm going to do a reflection in the x-axis. This is where your gold sheet comes in. Turn to your gold sheet, and on it it says a reflection across the x-axis. By the way, in the x-axis, on the x-axis, across the x-axis, it all means the same thing, so you can use that same note off your gold sheet. And across the x-axis, it tells us to keep the x the same and change the y to its opposite, or negative what it already is. So I'm going to put that note to myself down here as I go to change all my ordered pairs. So remember, this is my second change. So I'm going to call these A double prime, B double prime, and C double prime. So I know that it's my second change off my original. So A, I leave my x the same, and I'm going to go opposite my y. So it was 1, it becomes -1. B used to be -3 for my x, that stays the same. The y used to be 3, I go opposite that, so I go -3. And my C, my x stays the same at -2, my y goes opposite, it was 2, so now it's -2. There are my new points for my double prime, so I'm going to go ahead and graph those. Now, if somebody asks me what's the final answer to this question, these final 3 points in that final triangle I drew on the graph, that's my final answer. So a glide reflection has a glide followed by the reflection, and this is my final answer with these 3 points. When you do your homework tonight, I do want to warn you that sometimes when you do these, not all of your pictures are going to fit on your graph. So sometimes just figure out all your ordered pairs like we just did and graph just the final set of ordered pairs, because it might be the only thing that fits on your graph. Let's turn to page 2. So starting on page 2, we start with a theorem at the top of our page. Composition theorem. It says the composition of 2 or more isometries is an isometry. And we don't know the definition of isometry yet, so I've included that here on our notes. An isometry is something of side and angle measures. Remember from chapter 4, we learned 3 different transformations. The first one was a translation where we would slide it across the graph. This will definitely preserve the lengths of sides and angle measures because our shape doesn't change, it just slides somewhere. Our second one was reflections, where we take a figure and we flip it over a line to reflect it. Once again, this also preserves the lengths of sides and angle measures because, again, the figure doesn't change in size, it just moves across the graph across a line. Our third one from chapter 4 was the rotations, and again, we rotate around a point, but our lengths of sides do not change, our angle measures do not change, our shape stays exactly the same size. So once again, this preserves the lengths of sides and angle measures, so rotations are also an isometry. I do want to add, so you know the difference here, in chapter 6, we dilated figures. This is where we stretch them to make them bigger, or we shrunk them to make them smaller. And if you recall, we actually did that after first semester exam. We did 6.7 right to start our second semester. So those dilations actually shrink and stretch. Those lengths of sides are changed. The angle measures did not, but the lengths of sides do. So dilations is not an isometry. So this theorem tells us that if we mix any of the 3 translations, reflections, or rotations, and we mix 2 or more of them together, our figure should still always stay the same size and always the same angle measures because all of those moves are isometric. So let's go ahead now and move on to this, to an example of a composition of transformations. This is not the glide reflection anymore. So you'll notice in the margin, I put you a little note here. I've already used this on the first page, and it's something that you probably recall. You don't have to copy this into your margin if you know this. It's just a reminder that when we move our first transformation, we call it prime, A prime, B prime. Second transformation, we call it A double prime, B double prime, and so on until you reach the last. So this is a reminder. You don't have to write that in your margin, but I did want to put it somewhere in our notes just as a reminder for someone who might not remember that. So on our image of our composition this time, we are going to just take a segment. We're not going to do a complete triangle like we did in our last one. And we're going to graph this segment CD. So I'm going to go ahead and take my 2 points, negative 2, 6. Sorry, head messing with my stylus here. So here's my figure to start with, CD, and once again I'm going to write my ordered pairs over here so I can write and figure out where they'll go in each move. So this is my original XY. And my first move, let me change my color, is going to reflect across the Y-axis right there. And again, this is a gold note for us. I go to my gold notes and it says across the Y-axis, I'm going to change the X to negative and my Y is going to stay the same. So that's what I'm going to come down here and do with my values. So I'm trying to find C prime and D prime now. So my X was negative 2, its opposite is going to be positive 2. My Y is going to stay the same at 6. My D was negative 1. I'm going to do its opposite, which is positive 1, and the Y is going to stay the same at 3. So if I go ahead and graph these, here's my C prime. My D prime comes right here. And here's my new one after one change. But this is a composition one, so we're going to do a second change to add to this. Changing my color again. This one is 90 degrees about the origin. Again, go to your gold notes. And just a note here, all these rotations are counterclockwise. That's how all of our notes are. So as long as we're all consistent in that, we will always go counterclockwise. There is a chance if you use a different textbook, they could go clockwise, but usually the standard is counterclockwise. So I'm going to try to turn my C prime, D prime 90 degrees about the origin. So I'm going to go kind of towards the left as I go counterclockwise when I turn this. My gold note says when I go 90 degrees, I'm going to go opposite the Y first and then X. So the way we kind of work this when you think about what's happening here is I'm going to take my Y value and bring it to the front and do its opposite sign. So I used to have 6 as my Y. It's going to go opposite in the front, so I get negative 6. And then my old X value of 2 is going to just jump to the back. It's going to become my new Y value. And that's going to be my C double prime. For my D double prime, I'm going to once again take my Y, jump it to the front and put the opposite sign, so negative 3, and then move my X to the back, which will be 1. And that'll be my D double prime. So going ahead and graphing this, I'm at negative 6, 2. And that's up here in the second quadrant, C double prime. And I'm going to negative 3, 1. And there's my D double prime, and I'm going to graph those together. And there's my, again, my final answer. So if someone asks again, what's my final answer? It would be these points, negative 6, 2 and negative 3, 1, because that's where I finally land after both, or my composition of my transformations. So let's move to the bottom of our page here. In example 1 here on the checkpoint, I'm going back to the triangle from the first page of our notes. Okay, and just so we know, I'm going to copy down those same coordinates that I used on page 1. So on page 1, A was at 2, 1. B was at 5, 3. And C was at 6, 2. Now you'll notice with this example, I don't have to graph it. I like this type of example, something I'll use on a quiz or test, because I'm just checking to see if you know how to handle these. You don't have to graph everything. So right now I'm just going to go through the 2 transformations. And it's super important that you follow them in the order they give them to you. You don't get to do them in the order you'd like to do them. You need to do them in the order they give them to you. So the first thing they tell me is translate 5 units down. You may have practiced this, writing this coordinate notation in your transformation review homework. But if you remember, 5 units down is going to affect my y, okay? That means my x is not changing. So x is going to stay the same, but y is going to go 5 units down, which takes our y minus 5. So I'm going to find my a prime, my b prime, and my c prime. For a prime, my x stays the same. My y is going to be 1 minus 5, which is negative 4. My b, my x stays 5. I take for my y 3 minus 5 and get negative 2. And for my c, my x stays the same, and my y is going to be 2 minus 5, which is negative 3. So that takes care of my first transformation. Now I'm going to switch and do my last transformation, and that is reflected in the y-axis. We just used that one, but again, always check your gold sheet if you're not sure. That means my x is going to go opposite, but my y is going to stay the same. So I'm going to find my a double prime, my b double prime, and my c double prime. So for a, I take my x, which is 2, I go opposite, I get negative 2, and my y stays at negative 4. My b had an x of 5, I go opposite, which is negative, and my stays at 2. And for my c double prime, I'm going to take opposite my x, so negative 6, and I leave the y the same at negative 3. And again, these 3 points are my final answer because that's my composition of here of my transformations. And in fact, this one's another glide reflection because the first thing slid it across my graph and the second one reflected it. All right, now for example 2 here. It says graph the segment CD from up above in example 2 and do the rotation first followed by the reflection. So the question is, does it change things if you do them in a different order? So let's start with C and D from before. So C was at negative 2, 6 and D was at negative 1, 3. Go ahead and graph those on your graph. So this starts out the same way our example 2 started before. And now this time we're going to do the rotation first. So that 90-degree rotation from before, remember we're going to take this xy, and before we did the same thing, we're going to do negative y, x, because that's how a 90-degree rotation ends up. So my negative y, I take my 6, I'm going to make it opposite so it becomes negative 6, and my x just flips to the back, so negative 2. And then for D, I'm going to bring my y, which was 3, go opposite, make it negative 3, bring it to the front, and my x of negative 1 is going to flip to the back. And I'm going to call those my C prime and my D prime. So go ahead and graph those. And if you're peeking back up at that early example, you're going to notice already this is definitely, in that earlier example, we never went into the third quadrant, and this time we're definitely in the third quadrant for that first move. Now we're going to do the reflection next. We're going to reflect across the y-axis, and if you recall the move we did there, our x goes opposite and our y stays just where it was. So for our next move here, my negative 6 becomes positive 6, and my y stays at negative 2. That's going to be my C double prime. On my D, my negative 3 that I had becomes positive 3, and my y stays the same at negative 1 for this one. So here's my new C double prime. And here's my new D double prime, and there's my figure. So when we did our example from above in the opposite order, we definitely got a different graph. And again, I want to stress the one rule I told you from page 1. Always make sure when you're doing these that you always take your newest set of points and keep moving to the right with those. Don't go back to the original when you're making your changes. When we do compositions or glide reflections, we always start from our first point and keep moving from our changes. We don't go back to our original. Let's move on to page 2. I'm sorry, page 3. So we start page 3 with a theorem up at the top. This theorem deals with if we make a double reflection. So what we want to look at right here is, first I'll just fill in the blank on our theorem and then kind of explain a little bit more. It says if lines K and M are parallel, so we're talking about these two lines right here. If these two lines are parallel and these are my reflection lines, then what we're going to do is take our figure here, and they're just using a segment, QP. If I take my original QP here and I reflect it over the first line, so here I have my reflection, I get Q prime and P prime. Then I take this new reflected segment and reflect it again over here, and I get Q double prime and P double prime. What we want you to notice is if you started with your original figure Q and P, and you move to Q double prime and P double prime, and you skip everything in the middle, that double reflection looks the same as a translation. And that's what we're putting in that blank, translation. So a double reflection over parallel lines looks like a translation. Now a couple new things to add to that they add here in our theorem box says that if you join P to P double prime over here, you'll notice that it's perpendicular to my two reflection lines. So that's one thing to notice. The other thing they want you to notice is there's a distance between your two reflection lines. They call that D here. But if you look from P all the way to P double prime, it's going to be exactly twice that distance. And another thing to notice is if you also joined Q to Q double prime up here, it's going to be exactly that same 2D as well, because it's also been reflected from the same two reflection lines. So let's use that as we go on to example 3 here. So we're in example 3. It asks us various questions off this picture. So let's go first to our A and answer that one first. A asks us the question, or says to name any segment congruent to each of these segments. So the first one we start with is GF. So GF was my original segment here. I reflected it over here. Well, a reflection is isometric. We talked about that earlier. And because it's isometric, that means my length didn't change. So that means my G prime F prime here is also the same length. So G prime F prime is also the same length as GF. When I reflect G prime F prime over here to G double prime F double prime, it also is isometric. It does not change the length with the reflection, so that's also the same length. So G double prime F double prime is also the same length as G prime F prime and GF. Now our next one we ask on is FA. FA is down here. F to A is the length from point F to the reflection line K there. But if one of the meanings of reflection is you move things the same amount of space away from the reflection line. So the point from F to A is going to be the same from A to F prime because it moves it the same amount of space away from that reflection line. So FA is going to be congruent to the segment AF prime. And by the way, the order you write that in doesn't matter. I'm just trying to keep it left to right as I kind of read it. Then it goes also to this top one, GB up here. And again, that's G is a space away from the reflection line. So it should be an equal number of spaces away from the reflection line when it goes to B and G prime. So GB is the same distance as GB prime. And there you go. I wrote that one backwards from the one I wrote the last one. I hope that didn't confuse you. All right, we're on to B. Does AD equal BC? So it's important first we notice what we're talking about here. So AD is this distance right here. My pen, get my stylus to work here. AD is down here, and BC is right above it here. So a couple things to notice is we know our reflection lines are parallel. And we had the theorem up above that said that if they're parallel, these lines that join those are going to be perpendicular. So when you think about that, what I have is parallel lines also perpendicular. If we go back to chapter 8 and think about if we have a parallelogram, which we do, and we have right angles, we know we have a rectangle. So if we have a rectangle, are those two, that top and bottom line, congruent? Definitely. they're going to be equal in length because we have a rectangle. And that comes here. By the way, I'm going to put perpendicular in that space. So what we write down here is, yes, AD equals BC because G and G prime and F prime are perpendicular to both K and M. So that made opposite sides of a rectangle, which allow those to be congruent. All right, we're moving on to C here. So as we move on to C, it says, what is the length of G to G double prime? So if you think about it, I'm starting all the way here and moving all the way to here. So some of the things we didn't write down yet, up above it said FA was 6 and D to F double prime up here was 3. Well, using our rule from earlier, if this is 6 here, inside from A to F prime also has to be 6 because they're equal distance apart. And if D to F double prime is 3, also inside, we should get a 3 in here. So in between my two parallel lines, I get this distance of 9. We have a theorem up above that said if this is 9, from our original point, F, all the way to F double prime should be double that. So double the 9 should be 18. And you can see my numbers, if you add those up, they should also equal 18. So coming down here to C to fill in the blanks, by the properties of the reflection, F prime to A will also equal 6. And F prime to D will also equal 3. And that means that if that's the same on the bottom, because this is a rectangle up on top, it's also going to be 9 in the middle there, or 2 times that. So again, we kind of did all this math earlier, but if you want to add the blanks like they did, this is what it would mean. So if the bottom, F to F double prime is 18, then also G to G double prime will be 18. And that's the question they actually ask us. All right, moving on to the last one on this page. Okay, we could use a little picture to finish this one. It wants us to use a similar picture, or actually the picture from up above on example 3. So I'm going to see if I can somewhat recreate it. Remember, we have these two reflection lines. Let's see what they call them, K and M. So we have those two reflection lines. Let me change colors. I have GF again here. Here's my GF. I don't know if I'm going to be able to do this well here with the stylus. So G prime F prime is going to be in here. And then again, we reflect it one more time over here to G double prime F double prime. We need a few more labels in here. B was right there. In between G and G double prime is C. In between F and F prime is A, and in between prime and prime. Okay. Just getting us a couple things here so we can figure this question out. All right, they're telling us here that BC is 10. So B to C, this is going across here, is 10. And they're telling us G prime F prime is 6. So this line right here and here is 6. And it says, what is the perimeter of quadrilateral G double prime, so I'm going from here all the way to here, down to F double prime, and then over to F. So it wants to know this big green parallelogram I have going here, what is its perimeter? All right, so things to think about. G prime to F prime is 6. That means GF is also 6, and G double prime to F double prime is also 6. We know B to C here is 10, and that's between the two parallel lines, so we have that rule that from G then to G double prime should be twice that. So that'll give us a 20 there, which gives us a 20 here. So when I go to find the perimeter, I have two sides of 20. I have two sides of 6. So altogether, my perimeter for this figure should be 52. And I think we're ready for the last and final page of our notes, so let's flip the page. Once again, we're going to start this page with a theorem at the top. And this one deals with double reflection lines again, but the difference on these reflection lines is these reflection lines intersect. On the last page, our reflection lines were parallel. This time, our reflection lines intersect. So when our two reflection lines, we have reflection line M, we have reflection line K, they intersect, they form an angle in here. We didn't have this angle in the last time because they didn't touch, they were parallel, but now we form an angle. And what happens now with our figure is we take our original segment AB, we reflect it once to A prime, B prime, and we reflect it again to A double prime, B double prime. And what our theorem says is if we went from here all the way to here, it's the same as a rotation. I don't know if I can write this tiny on this line. Rotation in here. And it says about, and it's going to be about point P. Now point P is where my two lines intersect there. There's my point P. Good luck reading that one. All right, so this, when we had two parallel lines from AB to A double prime, B double prime looked like a translation. But now when I have two intersecting lines, the transformation from AB to A double prime, B double prime looks like a rotation about the point where the two lines intersect. And the only thing you really need to worry about is how much of a rotation it is. And we have this little angle in between my two reflection lines, and when I go from here to here, it's going to be twice that angle. So we look down here at example 4, and we have, on example 4, I have a blue, looks like a lightning bolt here. F is my original figure. I do one reflection across line K, and I land over here to F prime. And then I reflect that over line M, and I land down here almost like I would be looking in my third quadrant to this final lightning bolt down here. That's my final figure. So I'm going from F to F double prime. And the question that I'm asking here, or I should say that the book is asking, is how much of a rotation it is. Well, between K and M, we have an 80-degree angle. And by the way, we always go with the acute angle when we do this. We don't go with any obtuse angles. So I have this 80-degree angle. So when I go to find my single transformation, I'm going to do twice that 80 degrees. So I'm twice that 80. And of course, this is a rotation around point P, because P is where my two lines intersect. So when I go for my final rotation, I have a 160-degree rotation about point P. So moving on to my last and final example here, I'm moving this shape L this time. So I'm moving the L shape. I start down here at the bottom. I'm going to reflect once over to G prime, which is here in the kind of my first quadrant, and then reflect across line M over here. And the question is, what is my transformation if I went from L, this L from G all the way around to G double prime? So that means I'm going to go twice my angle. My angle is 68 degrees here. So twice my angle is going to be 136 degrees. And it's about or around point P. And remember, this is a rotation, is what the double reflections around two lines that intersect will give us a rotation. Double the angle, so that's where my 136 comes in at, around point P. And that's it for our notes. So you have a worksheet tonight, that 9.5 worksheet you're going to find. And again, just a quick reminder, not all of your graphs will fit there, but your final answer should always fit on the graph. So good luck, have fun, and send me any questions you have.